Hello, is everybody ready? Are you ready? Are you guys ready? To Are you guys ready to see the light? Okay, this particular lab is about the light. What is light? And I have a question for you. What is light? Yes? Yes? Light. What is light? Have you seen light over here, over there, everywhere, right? Without light, we cannot see anything, right? What? You have an idea what it's made out of, where they come from? We are going to give you an idea where light comes from. So light is an electromagnetic. You have magnets over here. Radiation means that it spans from point A to point B all around. It's propagate at certain speed, right? That is light. So, do you see color? You perceive color. Colors come from light, right? Colors of light are related. Colors is only a fraction, small fraction of all the possibility of different electromagnetic radiation. That's a visible side of the spectrum. That's what we perceive. But where color come from? Do you have an idea where color come from? Yes?
It's like when the light, when light is moving one side.
Sometimes, right. There are different wavelengths that are related to color, right? So, but the origin. Have you heard about atoms? You know, all matters are made out of atoms, right? All material objects are made out of atoms. There are different types of atoms. And the atoms are composed by a nucleus of protons and neutrons and the electrons zipping around that nucleus. We are going to focus on the electrons. When we excite, means we put power, fire, electricity, plasma to an atom. Those electrons in an atom jump out to the outer shell, and when they recoil back and recover, they emit that energy they absorb. They emit that energy in the form of photon, in the form of colors. And that is what we are going to see. We are going to understand different atoms, how they excite, and how they emit different color light. But in science, we don't care about the color. They might be pretty, they might be shiny, they might be different type of color. But we don't care about it. Because in reality, in the universe, there's no color in the universe. Atoms, they don't have colors. We care about the numbers. We quantify, we classify into numbers. In number, we can add, subtract, and so on and so on. That is science. Art, you deal with colors, pretty, this, dark, shadow, whatever you decide, you like, dislike, whatever you decide, that's art. In science, we deal with numbers, and that's what we are going to do. We are going to use different color light to identify atoms based on their emission. Let us do that. Let me see how it works. We have some gases over here. Table number 2, you have those gases in there in order, and you can describe the color of the gases. Then I will apply a scientific method and I will measure the wavelengths to classify those gases. You can write the color of this one. Which one is this one? I cannot see it. Helium. You have helium over there, right? So what color is this one? I cannot see it. You describe. Everybody perceives color differently. I don't know. You classify whatever you have there. This one? Hydrogen. I don't know how you call this color. It's up to you guys. It's perception. This one? That one? Over here? Krypton? Does that sound familiar? Krypton? Yeah, kryptonite? No, it doesn't exist. Krypton is a gas. And this one? Argon. So we are going to use this little device over here to quantify. We are going to run away from art, and we are going to become this scientific now. but we go there with numbers. Whenever we have that particular gas, which is this, which one is this one? Helium. We have three peaks. One is at 588 nanometers. The other peak for the same is 667 nanometers, and the other one happens at 708 nanometers. Guess what? If scientists go to with a telescope, a special telescope, and point to the stars, and they see those peaks, they kind of, for sure, say that that star contains that particular gas. There's the next one, hydrogen, very common. Sun have this one over here, and the maximum wavelength for the sun for the hydrogen is 655 nanometers. So if you point out to the sun with a telescope, you will observe that particular spectrum. We call it a spectrum. Next one. This one is neon. Neon have a lot of it. You are too young, you don't know the neon light. Before we have pics and all that, we used to have neon signs and all that all around, and they have a lot of pics. I would select only one here, would be 640. Next one, krypton. Yes, we have the kryptonite. Kryptonite doesn't exist. This one we have two peaks, and I would call this. I would select only one here. 761. That's the maximum. And the last one will be argon. Has a lot of peaks, right? Let's select this one. Will be 588. So we became this science now. We can use these colors to identify unknown gases. Whenever we have those wavelengths, we can sure we have those gases present. But for you guys here in the lab, we have a different application. We are going to move over there, but before that, we have some instruments that is based on that. We can identify metals and gases and using those instruments over there. Do you ever put a metal in the microwave? No? No one has done that here? No one? Good. You never do it. Do not do this at home. Please do not, because you will have a lot of spark. You have flame. You will excite atoms, and that will be dangerous. Never ever do that. Those instruments, we can do it here with these instruments to identify. But let us go move over there to the corner